My name is Ron Baziaco, and in today's video we're going to look at a GCSE math question I saw online, and I don't know, I thought it looked fun, so I thought I'd give it a try and give you guys a solution here. So basically we're given a circle with a point at the top that has coordinates 3p, comma p. We're also given a line segment that I can highlight right here. That's tangent to the circle and intersects the x-axis at point B, which is 16, 0, and we're asked to find the value of p. And I think there's a couple things that should jump out at you when you first encounter this question. One is that you know that the equation of the circle, just move over, is x squared plus y squared is equal to the radius squared. And notice how the x and y value of this point both have a common term, p. So we can just plug that into the formula. 3p is going to be our x, and p is going to be our y. We can see that as long as we have our radius, we can just easily figure out what p is because there's a correlation, you know? Even though this equation up here has three variables, x, y, and r, when you can write x and y in terms of each other, it turns it into a two-variable equation. And so you can simplify this. 3p all squared is going to be 9p squared. And that just gives us that 10p squared is equal to r squared. Or p squared is equal to r squared over 10. And I'm going to write this in pencil because it's important. P is equal to the square root of r squared over 10. So this right here is actually something, this is already good work to start it off. You know, like before even really looking at anything else, just by looking at this one point P, we have a general equation where if we can find out the radius, then we're going to be able to solve this problem. And so the other thing that I want you to look at is, I don't know how that in white, this 30-degree angle right here. And this is extremely important because I'm sure you've learned now that there's such thing as 30, 60, 90 triangles. Or if you have a triangle, a right triangle, with angles 30 and 60, that it will always follow this kind of general thing where if you have one side length, you can figure out the other two just by multiplying or dividing. And this is actually extremely important because I also want you to look at right here. This is the only measurement we are given in the entire question, is that this point B has an x value of 16. And so obviously you know that we're going to use this because if we weren't given this measurement, this circle could be infinitely big or infinitely small. And knowing that it's 16 is important. So we know that we're going to use this 16 in some way with this 30, 60, 90 triangle because it's the only thing that makes sense. Now, I'm going to draw a circle for a minute here. I'm going to draw a radius of the circle. Now, if I were to draw a tangent at the same point, what do you notice? I hope you notice that it creates 90-degree angles. And this is important because if we choose any point on a circle and draw a tangent to it and draw the radius to it, it's going to create a 90-degree angle. And it's important that you notice, because if we look at this equation, we see I've highlighted in yellow that that's a tangent. We can then draw a line, which is the radius of the circle. When you look at that, that creates a 90-degree angle. Now, if you look closely at this triangle right here, that is a 30, 60, 90 triangle. Or in red here, this is the 90-degree angle, that's the 30, and this is your 60. It's also important to notice that this 30, 60, 90 triangle, the hypotenuse starts at point 0 and goes all the way to point B, which means that this hypotenuse length is actually 16. So let's draw a more neat diagram of this. So we have our 90, we have our 30, and we have our 60. We know the hypotenuse is 16. And if you go back up to this diagram, you can see that the hypotenuse is always double the side length that's across from the 30-degree angle. So we know this is going to be 8. And lastly, we know that the side length across from the 60-degree angle is this root 3 times bigger than the one across from the 30. The one across from the 30 is 8. So this one is going to be 8 times root 3. Now what does this triangle mean? Well, if you look here, I know it's a little bit messy, but the radius of the circle that I've drawn, this is actually 8, because this is the side length that is across from this 30-degree angle, just like how I did in the drawing. The radius of our circle is 8, which means that this is also going to be 8. Now let's go back to my little formula I had here. P is equal to r squared over 10 rooted. So I'm just going to plug in 8. P is equal to the root of 8 squared over 10, or P is equal to the root of 64 over 10. P is equal to the root of 6.4, and that is our answer. You can see that just by kind of picking out what pieces are important at the start and reasoning with yourself, okay, my x and y coordinates here have a direct relationship, you can easily figure out what you're supposed to do. And I hope you guys enjoyed this video.